Hi, and welcome back from the tea break. We now have the penultimate session of the day, which is Digitize and Thrive, closing the skill gaps in renewable energy. And John Cosgrove is a principal investigator, and Gerard Cahill, a manager from the DigiWind team. And I know the sound is a little bit odd at the moment, but hopefully when you're on mute, that's going to sort it out. Okay, over to you, John.
Thanks very much, and I hope everybody can hear us okay. You can put a comment into the chat maybe if there's any problems, but yeah, delighted to be here. I'm director of the IDM Research Institute at the Technological University of the Shannon, and that's based in Limerick City in the west of Ireland. So we're going to talk in this presentation around a project called DigiWind, but also more generally around digitalization and AI and the future of skills needs and the future of talent development in the wind and energy sector. So let's see if I drop down. Okay. As I said, I'm joined today also by my colleague Gerard Cahill, who's the manager of the DigiWind project, and we'll explain that a little bit further on. But as you've probably heard, and if you attend any of these events, you'll know the scale of growth that's planned around offshore wind energy development right across Europe, right across the world. You can see some of the identified areas in Ireland. Some are off our southeast coast, some of our west coast, and all along the east coast, right up to Scotland. So we have targets of 5 gigawatts of offshore energy in Ireland. We're maybe on target to develop 2 if things go well. But across the EU, there's 46 gigawatts planned by 2030, and that's on target. We know we need across Europe over 45,000 new jobs, engineering primarily, jobs in offshore energy. And the same again within supply chain companies and manufacturing and facilities and ports and stuff like that. There's huge funding going into the area, 20% growth rates predicted over the next 20 years or so. So the big challenge is with all of this growth and expansion is how do we actually build the future workforce? Where are we going to get the talent and skills that are going to be needed to successfully implement all of these projects and all of this very welcome development? So in the, I always like to make the point that the offshore wind energy and a successful implementation of offshore is very dependent on having an onshore successful wind energy. By 2030, it's predicted that the offshore will be about 15% of the market, and onshore wind will be about 85% of the market. So we have to actually close the skills gaps in the whole sector, onshore and offshore together. And both of those sectors are absolutely dependent on electrical power systems and the electrical grid. So the skills and expertise needed to build out that grid and to plan and design and implement and do the maintenance and operations of all of that system needs to be sort of looked at in its round. And that's a very large number of some of the forecasts I'll talk about in a minute, but you're talking about hundreds of thousands of employees that need to be found in the next 10 years. And that's in a contracting labor market where there's a scarcity of talent already. We already have significant competition for engineering talent in particular in other sectors. So the boom in AI and the development of data centers is certainly both in Ireland and elsewhere hoovering up many graduates. The EU, the CHIPS Act, bringing semiconductor manufacturing back to Europe, is bringing massive investment into semiconductor fabs. Obviously, defense has become a very big spending area and growth area for manufacturing related to things like aerospace, drones, and munitions. Pharma, robotics, and advanced manufacturing are all growing very strongly. So in a very competitive employment market for engineers, wind energy and is going to have to compete for employees in that sector. you've seen, as I mentioned, the forecast that wind energy by 2030 was published in the last week or so, is essentially doubling from about 350,000 people employed across Europe in the wind energy sector up to 700,000 or 800,000 people. And that's in the context where at the moment we have a gap or a shortage of up to 2 million science, technology, engineering or STEM graduates. And that gap is getting bigger. In Germany alone, a report last year predicted that Germany would face a shortage of over 300,000 engineers by 2025. So, and there's many initiatives to try and change that. But it's a very challenging area to find and keep and retain talent. So that's been, I suppose, recognized. And if I just bring that down to the macro in Ireland, at a smaller scale, we have a national report that we need to go from around to just under 2,000 people working in the sector to somewhere between 8 and 12 or 14,000 people. Again, very difficult to see where the skills and talent are going to come from. In our case in Ireland, a lot of that growth is in the O&M operations and maintenance side, so that's quite of interest to us. So how do we get to that future of wind, and how do we bridge the skills gap? Our thesis, our suggestion would be that we do that through embracing digitalization. That if you only have 100 engineers to design out your wind farms, you basically need to give them better tools, better software, better models to allow them to double or treble the output that they can manage with the people that you have. So it is a question of innovate or stagnate. The other alternatives, which is to recruit many people into the EU, well, these jobs are in demand worldwide. So necessarily there isn't, and as we'll talk about in a minute, the adoption or application of digitalization and things like AI really need domain expertise as well. So the best person to use AI for designing wind turbines is a wind turbine engineer who has been skilled on AI. It's not a person who has come through a purely data science program and understands machine learning. The domain knowledge is very, very important. In some sectors, and we lead out a lot in advanced manufacturing, and it's probably a little ahead of a more traditional sector like energy. Many areas are already moving quickly to upskill their own engineers in AI, in digitalization, in intelligent systems, in software tools. And you know, there's quite a bit of projection as to how far and how fast that's going to grow. You've probably often heard the statement of AI won't take your job, but people who use AI, or people who are very good at becoming efficient and productive through the use of AI and intelligent tools, they might well take a number of your jobs. And again, from our background in manufacturing, it's very much in the last few years been an era of data-driven decision-making, data-driven insights, and that whole digital mindset that is growing. So we see that happening in the energy sector. And it is not just about the technical stuff. It's not just about AI. It's very much about using data and developing data at all levels of an organization, and using and informing the systems to make sensible decisions and to get insights into how we operate. So one of the challenges when we started the development of the DigiWind project, we spoke to many companies, and essentially what came across very strongly was that traditional engineering sectors, you know, the programs that people were educated on 5 years, 10, 15, 20 years ago, didn't encompass a very strong amount of computer science or computer programming or data analytics or cybersecurity. And those skill sets now are badly needed in the industry. And we see great opportunities for efficiencies, for better production outputs, for better design, for optimization of cable routing or layout of wind farms. You know, the tools that are becoming available and are becoming more intelligent have many benefits for the industry and the industry sector. And the Digital Europe program is funded by the European Commission, is to grow specialist education programs in these key areas: high performance computing, artificial intelligence, cybersecurity, and emerging digital technologies. And that includes a lot of areas, things like blockchain and credentials, things like robotics and automation, vision systems and compute, as well as AI and data analytics.
You seem to have gone on mute.
Apologies for that. I thought I'd just do a little explainer around, and it's in the PDF for anyone who wants it, around AI and generative AI. So we see some strong possibilities for the application of digitalization in the wind energy sector. But people need to understand that it's maybe not what you're seeing on the LLM or ChatGPT. Those generative AI aspects are useful for certain things, useful for scanning your emails perhaps, or managing your calendar, or writing a nice speech. But there's a lot of stuff in the deep learning, machine learning, and artificial intelligence tools that is very, very beneficial in it, particularly in an engineering context. And I took a quote there from a presentation recently I thought resonated very well, which is that AI is here in many big industries. It is being used. And the biggest challenge isn't how to use it, isn't what it can do. The biggest challenge is how much we can trust it, how much we can build comfort to use it, and how much we can have our systems depend on things that have been done with or in conjunction with AI. So just to link that to the wind and energy sector, we've had a number of projects both across manufacturing and also in wind energy around predictive AI. Lots of interesting applications, lots of nice ways of identifying what's happening in a rotor or a generator or in a transformer system, or looking at the metrology with the data and optimizing the control systems. And that's all around predictive maintenance or predictive AI. And it has a real application in maintenance and in operations. So generative AI, I describe more as being in this sector useful for CAD, useful for design. We can design better mechanical parts, better physical parts, stronger, better sustainability. It has lots of opportunities in CAD design, particularly in the wind and energy sector. And then hybrid AI is actually an area of great interest as well, because in these true engineering sectors, we do lots of numerical simulation already. We do lots of fluid dynamics. We do lots of flow, do lots of modeling with GIS and geographical data. We look at weather patterns, and there's a lot of very good engineering tool sets. Those engineering tool sets now work very well with predictive AI and with some of the tools that are developed and have been developing for more than just the last year or two, but have been developing for a number of years. I often advise industry that where you will meet AI in your industry is where you're already using CAD tools or control systems tools, or numerical modeling tools within the industry, but they will be significantly enhanced by what's developing in the AI field. So to mention DigiWind, we worked an awful lot with industry around the design and specification of this program, with an industry steering board and a survey out to many of the leading wind energy companies in Europe. We came across, and that was back in 2023, we came across a very strong demand for skill sets in big data and analytics, cybersecurity, cloud computing, and what you would expect, machine learning and AI, people with a view to the future. As we have entered into the project, and we're just finished month 18, so a year and a half into this project, we've actually been interviewing and doing one-to-one surveys with many companies and individuals across the industry. And areas like skills in scientific programming and software development have probably come to the fore, along with simulation, optimization, and modeling tools. But the data and the machine learning and the generative AI and large language models are also up there. And as I mentioned already, when we talk to companies about the application of AI, it is very much something that will support an expert that already understands whether the answer from the AI tool is good or bad, whether it's hallucinating or not, and whether it's a useful iteration in a design, or whether it's a useful trend or pattern that it has identified. So that human expert filter will be needed for a long time with many of these tools. So the DigiWind project is to develop master's programs to a great extent, as well as lifelong learning, and that's through a digital campus, digital master's programs, and a digital experience using the full availability of AR, VR, and virtual worlds. So as I said, it's from the Digital Europe funded program. It's funded for nearly 20 million euros. It's led by the Danish Technological University, DTU, who are obviously European leaders and world leaders in the wind energy sector. There are 5 pillar universities: TUS in Ireland, TU Delft, the Netherlands, NTNU in Trondheim in Norway, and Gdansk University of Technology in Poland. There's also a number of industry partners, WIFL, who I think are also presenting today, CAD People, IMR, and F6S, who are also involved in various ways with the industry. And the goal of the project is to develop a new way of delivering higher education to people at work. So people in the industry to upskill either through lifelong learning modules, short courses, webinars, micro credentials, but also building to a number of master's programs. And at this point, we have about 10 master's programs that are industry facing, that are available for registration pretty much at the moment. We're recruiting currently. And that will grow over the next 2 years to maybe 16 or 17 master's programs. We have around 50 lifelong learning modules currently advertised on our portal, and that's going to grow very quickly next year to over 100 modules, and I think probably significantly beyond that. So the goal is that we will create a single point of where people can go for upskilling around digitalization tools, digitalization approaches, AI, advanced digital, and be able to bring that into the wind and energy sector. And as I said, we've done this with a lot of industry input and a lot of testing the market with companies to try and make sure we're getting the right fit in terms of how that's implemented, and to try and bring new people into the industry. A key pillar is to recruit and upskill people from other industries to work in wind energy. We've developed a couple of these courses already, and I'll just skip quickly past them, but just to highlight the amount of industry speakers and guest speakers that we've had involved in our lectures and courses, knowledge days, and we did an online, very relevant to today, an online series on the Baltic Sea developments, North Sea, and then the Irish coast over a number of weeks with guest speakers from industry through all of that. So yeah, I think just to finish off, these are some live courses available from TUS. One is an MSc in Electrical Power Systems. We're registering students currently for that. It starts in October, but there's also an intake in January. And an MSc in Wind Energy Systems also open currently, and with a second intake in January. And the good news for anyone who comes to us on this fairly soon is that the fees are 100% discounted by the Digital Europe program and by our national funding body, Enterprise Ireland. That will vary as we go through next year and the following year. The discount will drop a bit, and industry will be expected to pick up more. But the same with some of the individual modules that are currently running on electrical power systems and simulation on smart grids. Excuse me. They're also 100% funded for the registrations in 2025. So there's a great opportunity there for people to send their staff from work, or send industry participants to these courses. And that's it for me. Hopefully you reappear, John, so I'm around the 20 minutes. So, and I hope I didn't skip quickly through all of that, but happy to answer any questions. And our website is idm.ie, and also the PDF of these slides is shared in the portal here as well.
Great. Thank you, John. I want to check the sounds, okay, but I can hear it coming back at me. Can you hear it going back at you?
No, I think it sounds okay.
Okay. Must just be my end. Bizarre. All right. Well, perhaps comments in the chat, folks, if the sound isn't good enough. Thanks for that. Thanks for that. You know, but when you say 100% discount, that presumably means people can do the masters for free at the moment.
Yep.
So there you
For
go.
2 years, it's 2 years masters, and it's free for the 2 years. Yeah.
Brilliant. Whereas I think people are generally paying, certainly in the UK, about £10,000 to do a masters. I think so. That's a nice incentive there.
Yeah.
Okay, great. Well, as usual, put any questions in the Q&A if there's anything you want to ask these guys about DigiWind and the programs they put together. In the meantime, let me ask a couple. How will the program support offshore wind and energy systems?
Yeah, I suppose we've again, DigiWind is really looking at the whole wind energy sector, but particularly in Ireland, you know, offshore has been a very live and very interesting topic because we're quite a bit behind in terms of development of offshore wind farms, but I guess maybe there's some advantages to that as well. We haven't had to do too much trial and error. We've got a good system in place now to start to build out the wind farms. We need grid capacity, but the training, so we've developed specifically led out of Ireland courses around offshore wind energy, one called Leadership in offshore wind energy, which was a really good, we've run it twice with very good feedback, really help people who aren't experts in the domain to understand all the different parts that are necessary to build offshore. Everything from the floating parts, fixed parts, to the environmental considerations, to the grid connections. So it's a really good overview. We've been asked to actually develop that out and maybe, you know, roadshow that around the country a little bit to explain to people what the key benefits and the key opportunities are for Ireland in this space.
Okay, thank you. And how will AI play a role in future digitalization within wind and energy systems?
Yeah, I think it's interesting. I suppose in full, we're still seeing the very early days of AI. We're seeing it do very silly things. We're seeing AI tools that hallucinate, as the new terminology is being used a lot recently, which isn't a good when you're launching a product like an AI tool to tell people that it hallucinates. But you know, there is huge benefits we've seen, and we've been involved in projects where, you know, maintenance costs on manufacturing equipment, for example, has been reduced by 30 or 40% because of the adoption of machine learning techniques and pattern recognition and future projection. I think if we're looking at offshore, where you need remote maintenance, the addition of robotics, self-healing networks, you know, there's many, the use of digital twins to manage the instantiation of the turbine that's at sea. These are techniques that are already well developed in some industries, but maybe not common yet in wind energy. So coming to this space, and I think there's significant cost benefits and time savings potentially available from that.
Okay, great. All right, thank you a lot. We'll call the session to close there. Thank you very much for your time today, and thanks for the interesting materials on DigiWind.
No problem. Thanks, Aaron. Bye.
Bye.